Scalability, it is limited by, so if we talk about scalability, so bottlenecks define the scalability. So scalability is limited by CPU bottlenecks. Scalability is limited by the CPU bottlenecks. So compute intensity. So processor at 100% utilization. So compute intensity occurs when the processor reaches 100% utilization. When the processor is fully occupied, 100% utilized, then uh, what will happen is that we will reach the stage of compute intensity. For example, when we are performing intensive tasks like image processing, encryption, or complex algorithms, there this compute intensity plays a role. This compute intensity plays a role. Queuing. So when the CPU is maxed out, it cannot process incoming requests fast enough, forcing them into a queue and leading to increased latency and timeouts. So what is queuing? Queuing, see, the idea is that when the CPU is maxed out, like when 100% of the CPU is utilized, compute intensity we reach, it cannot process incoming requests and we have to maintain a queue which will contain the incoming request, and it will lead to increased latency and timeouts. And here one very important law is there, Amdahl's law. This law, it states that in parallel processing, scalability is limited by the portion of the code that must run sequentially. Because if the code has to run sequentially, we cannot make use of it in parallel processing. So in parallel processing, scalability is limited by the portion of the code that must run sequentially. Even with more cores, the serial part of the task remains a fixed bottleneck. The serial part of the task, it remains a fixed bottleneck. So this is the CPU bottleneck. So now it's very clear that, see, the idea is to make the system scalable, but some limitations are there. And if we talk about the CPU limitations, thing is that when the load will increase, CPU will become compute intense. Like CPU will be fully utilized, and for more incoming load, we have to maintain a queue which will hold those requests, and hence it will increase the latency. So that is the CPU bottleneck. And also, if the process, it involves sequential code, then because of the Amdahl's law, we cannot achieve parallel processing. So the serial part of the task remains a fixed bottleneck. So these are the CPU bottlenecks which limits the scalability. So scalability, it is also limited by the memory. So if we talk about the memory limits of scalability, addressable capacity, addressable capacity. So the idea is that every system has a physical limit on RAM. RAM is limited. Once the RAM is fully occupied, the system cannot handle more concurrent user session or large data structures in memory. So that is the addressable capacity. So memory limit is a bottleneck because when we keep on increasing the load, after a point of time, the memory will get fully occupied and no more concurrent users or large in memory data will be supported. And then what we have to do, we have to do this disk swapping. In disk swapping, what we do is when the RAM is exhausted, RAM is fully occupied, the operating system uses swap or paging, wherein it moves the data to much slower disk. This drastically reduces performance and can lead to a thrashing state where the system spends more time moving data than processing it. And what will happen is when the load is continuously increasing because of the memory limits, uh, the RAM will be fully occupied and disk swapping will be done, wherein some chunk will be stored in the hard disk and from there it will be sent to the RAM when processing will be done. So disk swapping will be more as compared to processing. System spends more time in disk swapping rather than processing. So that will degrade the performance. And in languages like Java technology, we have garbage collection. So high memory pressure, it triggers more frequent and longer garbage collection pauses, which can halt application execution and kill scalability. So now it's very clear that scalability is limited by memory limits because memory is limited. So when we keep on increasing the load, after a point of time, RAM will get exhausted, because of which disk swapping will be involved, which will significantly degrade the performance. And in technologies like Java, garbage collection will come into picture, which will further halt and degrade the performance of the system. So this is how memory limits scalability. Now let us look at the how scalability is limited by the disk input output operations. How scalability is limited by the disk input output operations. So throughputs and input output operations. So storage devices, they have fixed the limits on how many input output operations per second they can handle. So see, storage devices, we make use of storage devices. They have fixed the limits on how many input output operations per second they can handle. Now heavy read write operations, because when the load will increase, heavy read write operations will take place, and th- they will saturate these limits, and that is the bottleneck. And here latency will also come into picture. So mechanical drives, they have high seek times. Even with SSDs, if the application requires constant disk access, the CPU must wait for the data to return, stalling the entire process. So this is the disk IO bottleneck. So the idea is that when the load will increase, there will be more pressure on the disk, because of which uh, the read write operations, it will further slow down, and the performance of the system will degrade. So latency will come into the picture, and this is how the disk IO, it limits the scalability, because after a point of time, the system will not be able to further scale, further handle load. The system will break down. Network bandwidth. So now let us see how scalability is limited by the network bandwidth. How scalability is limited by the network bandwidth. Let us see how scalability is limited by the network bandwidth. Transfer limits. So see, in network also there is a transfer limits are there. So network, it is the bandwidth of the network is limited by the capacity of the network interfaces. So the transfer, like it can be 1 Gbps or 10 Gbps. If the volume of the data being moved, such as video streams or large API payloads, exceeds this capacity, packets are delayed or packets are dropped. So that's the transfer limits. Latency and congestion. Beyond raw bandwidth, the time data takes to travel between nodes, that is called as the latency limits. Latency, it limits how quickly a distributed system can sync. High traffic can lead to congestion, where network devices become the bottleneck. So now it's very clear that when the load will keep on increasing, so when we talk about the network, transfer limit is there. The transfer limit can be either 1 Gbps or 10 Gbps. It cannot be more than that. So when the load is increasing, it has to wait, because the bandwidth, it cannot support more than 10 Gbps of data transfer. So that's the bottleneck. And also latency and congestion will come into the picture. So latency is basically the time taken to travel, and high traffic will lead to high congestion. So when the load will increase, latency will increase, congestion will increase, and after a point of time, the system breaks. So network bandwidth, it limits the scalability. Now let us see how scalability is limited by the database contention. How scalability is limited by the database contention. So locking. So the idea is that to maintain data integrity, databases uses locks during write operation. so that if many processes they try to update the same record simultaneously, they must wait for the lock to be released, creating a stop and go effect that limits the throughput. So this locking is very important because when multiple processors tries to update the same data, they cannot update it simultaneously. So there is a concept of lock. So if the data is locked, it means somebody is trying to update it. And once the lock is released, then we can also update it. So this locking, it introduces the stop and go effect and it affects the throughput. And when the load will increase, when the load will increase, this throughput, it will further degrade because many more processors, they will try to access the record, update the same record. Connection pools. So databases have a maximum number of concurrent connections which it can support. Once all slots are taken, new requests from the application layer are rejected or queued. Centralization. A single non-sharded database often becomes the ultimate single point of failure for scalability as it cannot be easily split across multiple servers without significant architectural changes like sharding or replication. So now this is very important. Single non-sharded database, it becomes the single point of failure. Because of centralization, if you just use one database, if that fails, the entire system will collapse. And it's difficult also to distribute the databases because then we have to do that sharding, replication. So centralization is also a bottleneck because when the load will keep on increasing, we have to distribute the database. We have to balance the load because the single central database will not be able to handle the load. So now it's very clear that when the load will increase on the system, uh, database contention will be a bottleneck. More locking will be there. Uh, Database, it has a maximum concurrent connections it can support. So after a point of time, it may not handle more connections, and centralization in itself is a bottleneck. So this is how database contention, it limits the scalability. So every system has a weakest link, and this weakest link is the one which gets breakdown on increasing the load. So every system has a weakest link, and scaling means identifying bottlenecks and removing them iteratively. So scalability is all about identifying the bottlenecks and removing them iteratively. Like if CPU is the bottleneck, we can either go for vertical scaling or horizontal scaling, wherein we can either increase the CPU power or we can introduce more CPUs. So this is how we are. So the idea is that you are designing a system. You have to identify the bottleneck, whether the bottleneck is the CPU, the memory, the disk IO, the network, or the database. So identify the bottleneck and remove them iteratively. And in this way, you evolve the system. And as the system is becoming more and more scalable, it is handling more and more load, a new kind of a bottleneck you might identify. So the goal is we have to keep on watching the system, identifying the bottlenecks and removing them iteratively. And in this way, we can achieve scalability.